Hello students, today inshallah we are going to summarize the work which has been done within week 6, lesson 9.2 and lesson 9.3. By the end of this session you must be able to number 1 write congruence statements, number 2 use properties of congruent figures to find missing measures, angle or side length, number 3 apply properties of congruent figures in real life problems. Number 4, write similarity statement for two similar polygons. And finally, use properties of similar polygons to find missing side length. We will begin with lesson 9.2, congruence and corresponding parts. We will solve selected exercises from your textbook, pages 499 and page 500, and some selected exercises from the uploaded worksheet on the school resources. Write congruence statements comparing the corresponding parts in each set of congruent figures. The congruent figures here are the two triangles, triangle FGE and triangle HGJ. The corresponding angles are, it's very clear that angle F is congruent to angle H. Angle E is congruent to angle J. And angle FGE, angle FGE, which is this one, is congruent to angle HGJ. You can notice that the two angles have two arcs. And you can also figure out the congruent angles from the order of the letters here. Triangle FGE is congruent to triangle HGJ. So directly from the order of letters, angle F is congruent to angle H. And angle G, which is the vertex here, which is FGE, is congruent to angle HGJ. And finally, angle E is congruent to angle J. About the corresponding sides, you can figure it out also from the figure by how many dashes are there. You can notice that line segment FG has one dash, same as line segment GH or HG. So these two line segments are congruent to each other. And line segment GE, it has three dashes. So it's congruent to line segment GJ, and line segment EF is congruent to line segment JH. We'll move to exercise 5 from your textbook. In the well design shown, triangle RST is congruent to triangle RWX if measure of angle WXR, this angle is 62 degrees. What is the measure of angle STR? STR is this one. This is the unknown angle. And it's very clear that because the two triangles are congruent, triangle RST is congruent to triangle RWX, so angle WXR is congruent to angle RST, which is missing. So we will begin the answer by writing the given, which is the two triangles are congruent to each other. And then angle STR corresponds to angle WXR. Therefore, angle STR is congruent to angle WXR. Therefore, measure of angle STR equals measure of angle WXR, which is already given, equals 62 degrees. That's it. All of the point is about how to figure out the corresponding angles. So use the given and then find the corresponding angles. They will be congruent, then equal in measure, and that's it. And now let's apply congruence and corresponding parts in multi-step real-life problem. In the city park map shown, triangle DEF is congruent to triangle JKL. The distance from D to E is 20. This distance is 20 yards. And the distance from D to F is 40 yards. What is the distance from K to L? This is the unknown. We require to find this distance, which is the distance or length of line segment KF. Very clear that these two triangles are right angle triangles. And it's also according to the given, which is given that these two triangles are congruent. So length of line segment KL equals length of line segment EF. And line segment EF is in the right angle triangle DEF. And it is the hypotenuse in this right triangle. Right triangle, hypotenuse is missing, two legs are given, so directly this leads to Pythagorean theorem. So the first step will be applying Pythagorean theorem. Why Pythagorean theorem? To find KF, which corresponds to KF, which corresponds to, sorry, KEF, which corresponds to KL. Using Pythagorean theorem, hypotenuse equal leg 1 squared plus leg 2 squared, or hypotenuse equals side 1 squared plus side 2 squared. The hypotenuse here is EF squared equals line segment DE squared plus line segment DF squared. And then we will substitute by the lengths. Line segment DE squared will be 40 squared plus DF squared 20 squared. So, and 40 squared means repeated multiplication 40 times 40, which is 1,600. And 20 squared means repeated multiplication 20 times 20, which is 400. So DF squared is 1,600 plus 400, which is 2,000. But this is DE squared. We need to find just line segment DF. So we will take a square root of both sides. So we will get that line segment EF equals the square root of 2,000, which is 44.72 yards. And we will round to the nearest tenth. We will look at the hundredth, which is 2. 2 is less than 5. We will cancel it. So length of line segment EF equals 44.7 yards. And now we will be back to the figure again. The question was talking about the required to find is line segment KL, which corresponds to line segment EF. And now we found line segment, the length of line segment EF. We found EF. So it's easy now to use the congruent triangles. Triangle DEF is congruent to triangle DEF is congruent to triangle JKL, and KL according or as a result of the congruence. Line segment KL corresponds to line segment EF. So line segment KL congruent to line segment EF. So KL or length of line segment KL equals EF equal 44.7. So the the distance from point K to point L in the parking equals 44.7 yards. Let's move to some exercises from the worksheet which had been uploaded on the school resources. We will begin determine if possible whether the following pairs of triangles are congruent. If congruent, write ASA, which is angle side angle, or angle side, or hypotenuse leg. The postulate you use to conclude that they are congruent. If it is not possible to conclude that they are congruent, just write no conclusion. Let's look at each pair of triangles. Look at these two triangles, triangle PQR and triangle STU. Let's figure out which is given. The given here is angle P has one arc congruent to angle S. One arc. Angle Q is congruent to angle T. And what do we have in the middle? We have the included side. So these two triangles are congruent by angle side angle, which is ASA. Number 2, triangle ABC and triangle XYZ. Let's look at the given. The given here is angle A is congruent to angle X according to the arc. And line segment AB is congruent to a line segment XY. And line segment BC is congruent to line segment YZ. We don't have this case. There is no angle side side. So in this pair of triangle, no conclusion. There is no postulate to prove that these triangles are congruent. Number 3, triangle SUT and triangle WVX. Angle S is congruent to angle W. Angle T is congruent to angle X, and no more given. And to prove that the two triangles are congruent, we need 3 conditions. And in this case, we have just 2 conditions. So no conclusion. We cannot prove that these 2 triangles are congruent. About exercise number 4, very clear that these are 2 right angle triangles. 2 right angles triangles. To prove that 2 right angles triangles are congruent, we need the hypotenuse and one leg, because the right angle is already included because it's right angle triangle. Let's figure out, are these congruent or not? The hypotenuse in the first triangle, line segment PRP, is congruent to the hypotenuse DF, and the leg RQ is congruent to the leg EF. So these 2 right angle triangles are congruent by the postulate hypotenuse leg. About number 5, triangle ABC is congruent to or not triangle FGE. Let's look at the given. Angle A is congruent to angle F. Both of them have 2 arcs. Angle B is congruent to angle G. Both has only 1 arc. And here is the side. Line segment AC is congruent to line segment EF. So these 2 triangles are congruent by angle side. And let's move to exercise number 6. Number 6 has a little different idea. We need to back to term 2. In term 2, we were learning about vertical angles. These two angles are vertical, so they are congruent. Let's go to the triangles in exercise number 6. Directly, these two angles are vertical, so they are equal in measure, which I ticked with red. And angle M is already given, congruent to angle K, and the line segment MJ is congruent to a line segment KJ. So I rearrange the given one more time. Angle HJM is congruent to angle KJL. And the side JM is congruent to side JK. Here is the side. And angle K is congruent to angle M. So these two triangles are congruent by the postulate angle side angle. Find the value of X so that the triangles are congruent. The triangles here are congruent by side, side, side. Why? Because it is already given in the question, find the value of X so that the two triangles are congruent. And there is no given about the angles. So they are congruent by side, side, side. Where are the sides, teacher? These two sides are congruent to each other. And these are congruent from the given. And here is the common side. Okay. So 20x, because these are congruent, and these two sides are correspond to each other. So 20x equal to 22x minus 3.6. We need to solve this equation. We need to get rid of the number or the variable, which is with 3.6. We will add negative, or we will subtract negative 22 from both sides, just to keep one side with variable and the other side with number. So we will get that negative 2x, we will subtract negative 22, negative 2x equal negative 3.6, and then we will divide both sides by negative 2 to get rid of the coefficient of x to isolate x. So we will divide negative 3.6 divided by negative 2. Negative divided by negative will be positive, and 3.6 divided by 2 is 1.8. And to check your answer, you can just simply substitute by the value of x in both sides. You will find that they are congruent or equal in length. And now let's move to lesson 9.4. Similarity and corresponding parts. We will solve also some selected exercises from your textbook pages 521 and 522 and the uploaded worksheets on the school resources. We'll begin with a very simple exercise to just clarify the idea of similar triangles. In similar triangles, we should know the difference between similar and congruent triangles. In congruent triangles, the six elements are the six corresponding elements are congruent to each other. So all angles congruent to the corresponding angles, all sides are congruent to the corresponding sides, but similar triangles are different. In similar triangles, the angles always are congruent, but the sizes are proportional. So in similar triangles, the angles are congruent, but the sides are proportional. What does this mean? We will figure out. And this also congruent. Question number 1, use the figure for exercises 4 and 5. The triangles are similar. Similar triangles have congruent angles and proportional sides. They have same shape but different sides. Name the pairs of congruent angles. I already highlighted. It's very clear that angle A is congruent to angle F because they have one arc for both. Angle B is congruent to angle E. Both have 2 arcs. And angle C is congruent to angle D. They don't have any sign, but according to the third angle theorem, according to the third angle theorem, the third angle theorem tells us that, we learned this in term 2 at school. The third angle theorem tells us that if in the first triangle, 2 angles are congruent to each other, two angles in the first triangle congruent to 2 angles in the second triangle, so directly the third angles in both triangles are congruent to each other. Write the corresponding side length in the proportion below. What does proportion mean? Proportion means ratios are equal to each other. Proportional relationship is consisted of 2 or more ratios equal to each other. Line segment AB, this line segment is proportional to the corresponding side in the other triangle, which is EF. And line segment CB corresponds to line segment DE. And finally, line segment AC corresponds to line segment FD. Now let's move to this exercise from your textbook. Determine whether each pair of polygons is similar. If so, write similarity statement. We said to prove that 2 polygons are similar, we need to find that the corresponding angles are congruent and the corresponding sides are proportional. So let's check the angles first. Angle, look here, according to the figure, angle A has 1 arc, so it's congruent to corresponds to angle E, and also it's congruent to angle E. Angle B is congruent to angle F. Angle C has 3 arcs, so it's congruent to angle G. Angle D, finally 4 arcs, so it corresponds and congruent to angle H. So all of the angles in both polygons are congruent. So we're done from the angles. Let's go to the sides. To prove that the sides are proportional, we need to write each two corresponds sides as a fraction, as a ratio, and then simplify it. Let's begin. Line segment AB corresponds to line segment EF. So it will be, we will substitute by the length. AB equals 15. So it will be 15. Line segment AB equals 15. Line segment AB equals 15 over line segment EF, which is 5. And when we simplify it, we will divide both sides by 3. When you divide by 3, here you will get 1, and here you will get, we will divide both sides by 5. When we divide both sides by 5, here we'll get 1, and here we will get 3, because 15 divided by 5 is 3. So the ratio between the two sides, the two corresponding sides, AB and EF, equals 3 in its simplest form. Let's move to other two sides. Line segment BC corresponds to line segment FG. So 22.8 over 7.6. And when you divide this, you will get it in the simplest form, equal 3. And line segment DC corresponds to, line segment DC is 45, corresponds to line segment GH, which is 15. We will divide 45 by 15, you will get 3. And finally, line segment DA, which is 24, corresponds to line segment HE, which is 8. And when you divide 24 by 8, you will get 3. Look here, what did we get? When we simplify all of the ratios between the corresponding sides in the two similar figures or two similar polygons, we got the same number. So the sides or the corresponding sides in the similar polygons are proportional. If we get the same ratio after simplifying the same number for each ratio, after simplifying, this means that the sides are proportional. Now we got the two conditions to prove that the two polygons are similar. The corresponding angles are congruent and the corresponding sides are proportional. So the polygons are similar. And don't forget that the question here asks, if so, write similarity statement. Here we go. This is the similarity statement. Polygon ABCD similar to, this is the symbol for similar. And we read it similar to polygon EFGH. And here we go. We reached the last exercise. Each pair of polygons is similar. Find the missing side. The given here is that the two polygons are already similar. We need to find the missing side length or side measure. Let's look at these two triangles. Line segment, let's figure out. Let's write the name of the two triangles first. Triangle ONM is similar to triangle UTS. So we will use the similar sides to find the missing side. We will use the corresponding sides to find the missing side, which is X. UT, look here, line segment UT in this triangle, even if you look at the letters here, line segment UT is already given, and line segment ON, the length of UT is given and length of ON is given. So I can use the ratio between these two sides to help me find the missing value, missing side, which is X. How, Miss? We will write the proportional relationship using line segment UT over ON equals X, which is line segment US over line segment OM. So line segment UT over line segment ON equals line segment US over line segment MO. And let's substitute by the lengths. UT equals 10 and ON equals 4. Keep X as it is. Line segment MO is 5.6. And we will use here the cross multiplication to find the missing variable, which is X. So we will multiply 4 times X, it will be 4X. I think you know this very well. 4X equals 10 times 5.6. And then we will multiply 10 times 5.6 is 56. And now we need to solve this equation. To isolate X, we'll divide both sides by 4. Cancel 4 with 4. And here we will divide by 4. When you divide 56 by 4, we will get 14. So the length of the missing side measure or side length is X equals 14 units. I hope that you got the difference between congruent triangles and similar triangles. I'll summarize it one more time fast. In congruent triangles, the side lengths are equal. In congruent triangles, same like this, the side lengths are congruent and all of the side lengths are congruent and all of the angles also are congruent. But in similar triangles or similar polygons, generally, the measure of angles are equal or angles are congruent, but the sides are not congruent, they are proportional. The similar figures or similar polygons have the same shape but different sides. Wherever the congruent triangles have same shape and same size. Thank you very much. I hope that you got all of the objective, and now it's your turn to go open your textbook and worksheets and practice on these ideas. Thank you very much.